Welcome to 3.7. We're going to be talking about determinants and using determinants to find area of a triangle. So with each square matrix, there's a real number called the determinant. So it's only for square matrices, like 2 by 2, 3 by 3. Those are the main ones that we're going to be talking about. And so the notation for a determinant could either be determinant of A, or we can write it like this. So if I had A equals this matrix, then if I wanted to find the determinant, I would write determinant of the matrix, or I could write it in this notation. Either way is fine. We're going to see it both ways. Alright, this is the strategy for evaluating the determinant of a 2 by 2 matrix. So in the top example, you can see they multiplied the diagonals and took the difference. The important thing is that you multiply A times D first, and then you subtract C times B. So for example, if we wanted to find the determinant of 5, 4, 3, 1, we would need to multiply the diagonals. So 5 times 1 minus 3 times 4. Simplifying, we get 5 minus 12, and our final answer is -7. So -7 is the determinant for this matrix. Okay, I'd like you to try this one on your own, so pause the video and good luck. Okay, welcome back. Hopefully this is the work and the answer that you got. If it's not, find your mistake, and if you still have questions, please ask them tomorrow. Okay, so the determinant of a 3 by 3 matrix is a tad bit different. So following along with step 1 and step 2, it says repeat the first 2 columns to the right of the determinant. Okay, so I'm going to use this example down here. And if I want to find the determinant, first I need to put it in determinant notation. So I copy down the numbers inside the little determinant symbol. And step 1 says to repeat the first 2 columns. So I'm going to write the first 2 columns again. Don't do anything to them, just write them off to the side next to them. So if you didn't quite see what I did there, I highlighted them in gray. So I copied my first 2 columns off to the right of the determinant. So following along with step 2 in the example above, I need to take my diagonals. So I have 3 blue diagonals, right, starting in the very top left and ending in the very bottom right. Now I'm going to multiply those diagonals. So I'm going to get 2 times 1 times -2 and add it to the middle diagonal. So -1 times 0 times 3, and add it to the last diagonal. So -3 times 4 times -4. Okay, and I also have my red diagonals. So starting in the very bottom left, I draw my 3 diagonals ending in the very top right. And now I subtract all of those diagonals products. Now I wrote subtraction signs for all of my red products. In the example up top, what I did was I distributed my negative because I didn't want to write extra parentheses. So here's my negative sign distributed to all of my red diagonal products. Okay, it looks like I need to do some simplifying. So I will have -4 plus 0 plus 48 minus -9 minus 0 minus 8. So simplifying that even further, and I'll get 45. It's really important to pay attention to your signs. That's where a lot of the errors occur in these problems, is the negative signs, and so just be careful on those. Here's a little cleaner version of what we just did. If you like looking at it this way, go ahead, take a minute to look at it this way. I know their writing is a lot neater than my writing, so. I would like you to try this one on your own, so pause the video and best of luck. Okay, welcome back. Hopefully you got -21 as the determinant of this matrix. If not, try to find your error and ask questions tomorrow. So one of the things that we can use the determinant for is to help us find the area of a triangle when we know there are points on the coordinate plane. And the way we do that is we're going to take half times the determinant of x1, y1, x2, y2, x3, y3, and we're going to fill our last column with all ones so that we have a square 3 by 3 matrix. Now the little plus minus symbol in front of the 1/2, that means we get to pick either positive or negative for the 1/2. Whichever one will give us a positive area, because we can't have a negative area. So I just put dummy values in for x1, y1, x2, y2, and the third point. So pretend that x1, y1 is 1, 6. So to find the area of this triangle, I would have plus or minus 1/2 times the determinant of x1, and my x1 is 1, my y1 is 6, and I filled the last column with 1. Okay, so x2 I said was 5, and y2 is 4, and I filled the last column with 1. x3 and y3, and then my last column is 1. So now I'm ready to find the determinant, and we're going to do that the same way we did our other determinants. So repeat the first 2 columns to the right of the determinant, and now we do our diagonals. And I went ahead and figured it out. After we do our diagonals, we get -16. Remember though, we still have this plus or minus 1/2 out here in front. So we need to take 16 times 1/2 plus or minus. Now is when we decide if we want to do plus or minus. Well, we need our final answer to be a positive number. So we have -16. We need to multiply it by a -1/2, because a negative times a negative is a positive. So the area of this triangle would be 8 units squared. Okay, let's go over another example. This is a word problem, so yada yada yada, get to the end and it says use the determinant to estimate the area of the region. So we're trying to find the area of this triangle, and we know its coordinate points, and I rewrote them on the next page. So I'm going to label them. This is my x1, y1, This is x2, y2, and x3, y3. And I'm just going to color code them to help us out a little bit. Okay. So my x1 and my y1 go here. My x2 and my y2 are in the middle. And then my 3's are at the bottom. And remember, we fill our third column with 1's. And before we can do our diagonals to find the determinant, I need to copy in my first 2 columns. And now we should be good to go. Let me change colors. So diagonal. And another diagonal. So let's write it out. We have -1 times -43 times 1 plus 41 times 1 times 0 plus 1 times 38 times 0 minus 0 times -43 times 1 minus 0 times 1, -1. It's especially helpful when we have zeros, because multiplying by a 0 gives us a 0. Okay, now we're ready to simplify. Remember, don't forget we have that 1/2 hanging out here. So after we multiply, we're going to get 43 plus 0 plus 0 minus 0 minus 0 minus 1,558. Don't forget about our 1/2. And after we subtract, we get 1/2 times -1,515. Now we need to decide if we want our negative to be positive, if we want our 1/2 to be positive or negative. Well, we want a positive answer, so we need to multiply by a -1/2, and we get 757.5. So the area of that triangle is about 758 miles squared. Okay, here's one I would like you to try. I already plugged in your x1, y1, x2, y2, all of those, and I even rewrote the first and second columns for you, so everything is set up. You just need to find the determinant and multiply by a positive or negative 1/2. So pause the video and good luck. Welcome back. Hopefully you got 34 units squared. Try to find your errors if you had any and ask questions tomorrow. So we'll see you then.